And now share screen and share screen. Okay, and our session started officially now. About exam, guys, all instructors are doing their exams now. Most of them are doing first exam. We did our first exam, so we are ahead of them. If we want to keep 3 exams, yani 2 exams and a final, we have to do another exam before the final, guys. We have time to do it. So I'm gonna check attendance, number of students showing to campus, where are they coming from? I have students tomorrow, I have an exam, 3 exams tomorrow. Some students are coming from Bika, some students are coming from Akkar, just to do my exam. So they are managing how, I don't know, yani, you should be able to manage. We will talk about exam more and more as days proceed. لأنه I want to hear about others doing exam before I do my exam on campus for this course. لأنه I have, as I told you, one grade already. طيب. For today, we start with risk 5 programming. It's an assembly language. You might say that this is not of an importance to me and ChatGPT can write the program at any time. But remember, guys, it's always the fundamentals. You know, yeah, maybe your whole life you will not write code, but maybe if you go in your master's degree, you might see something like this and they force you to write, and at least you should be able to read an assembly language program based on what you have learned from courses in your university. Okay, so on Moodle, I have this assembly language, risk 5.1, risk 5.2, 3, and 4 samples. I already showed this, and for you to download and maybe follow with me, or you can follow the lecture and then you can download it and review. But it is there shown now. And in my case, I have it here previously. I don't know if I have this in the folder that's on Moodle, and I keep updating it, guys. Maybe this one, maybe it's not there. But anyways, you can figure it out. These are the registers that we have been talking about in ARM instruction registers, guys. So this is very similar to what you need to write in your assignment concerning ARM machine registers. لأنه الأسمبلي language هن الريجسترز تبع مين؟ تبع السي بي يو. So they are like one-to-one relation. So you will see in my samples the terms X, A, and T. So you see X0 or A0 or T0. They are the same registers, guys. But this is like when you write مثلا a web application with different roles. مثلا الكوتش عنده role, البلاير عنده role, المانجر عنده role. So these are the same 32 registers, but you name them in your program differently according what they are doing at that time. So if you see an X or an A or a T, you don't think that there are other registers. They are the same registers, but you name them this way for different purpose. What is the purpose? The purpose of this, for example, the raw numerical name of the register, often used directly in assembly. Numerical name of the register, most of them are called X in our programs. But when you call it an A, used for processing argument to a function, you know, when you pass parameters. So if you, for example, you want to set an offset, if you want to set an offset of an address, well, I might put it in A, not in X. X usually is for direct numbers and calculations. For the T, used for temporary storage. So I want to set something temporary. I can put it in X. I can put it in A. But if I put it in T, it will mean for the programmer, for the run, it will be the same. But for the programmer, it will mean, yeah, this I can use after a while, لأنه I use it temporarily. So this is not important, but I wanted to know that you will see X as a name of a register, A as a name of a register, T as a name of a register, and they are the same register inside the CPU, yet they have different roles. Having said that, now let's go to this. I will see when we learn any programming language, guys, you know that we go with the hello world. So right click. Oh, before that. No. Okay. Before I open this program, I have to know where to open it, how to open RISC-V interpreter. And here we go. So it's an online interpreter. Where am I? Okay, let me do this. Plus, خليها هيدي كده. Wait a minute. What am I doing now? Wait a minute. هيدا no. So this, I want this one. So I run it from here. And you search on the web for RISC-V Venus. RISC-V Venus. Okay? And enter. And you go to this kvakil.me website. And here you are running show, you are running Venus. Okay. We have the editor part and we have the simulator part. We will come to this part and identify each element. Editor. By the way, this is the fundamentals of the language we are learning. So just like when we started with Java, public static void main, scanners, and something else. So we have the editor and we have the simulator. Simulator is something that you had to write for one human machine into yourself. You wrote a program. طيب. Now you need to write a program here. You can write it directly here. This is an editor. So you can write it, or you can copy paste a program that you already have. Like in this case, open with Notepad, and this is my program, and Control A, and right click and copy, and minimize in case I want to come back to it, minimize this, and right click and paste. So this is the program, طبعا, with colors and everything to identify this and that. And this is the hello world in assembly, guys, using RISC-V assembly. And here we go. The dot data. In Von Neumann, we used to write the data at the bottom, guys, you remember? In Turbo Assembler, the one I used to teach, and in this, the data goes first. I don't know if we copy paste it down, if it will work or not. Try it. I didn't try it myself. No, it doesn't make sense. Yani, whether it's up or down, I write it as they like. Type. The data part. You know what this matters, guys? Saying dot data. لأنه the address that these variables will be stored at is in the data part of the machine. I'll show you now in the simulator where it goes. Fine. But let's keep with the syntax. Hello world is a variable name, guys. You can call it anything you want. N, Q, R, whatever we used to name them in Java or any other high-level language. Colon is a must for syntax. And then dot ASCII Z, and this means it's the ASCII of this value. So guys, this translates into for Java string hello world equal hell. Okay, فإذا it will translate into string, طبعا as capital letter, you know, in Java, Hello world is the name of the variable, and then the equal sign, and then quotation hell, quotation semicolon. You know the rest. They are the same. So I have three variables. Always, and again, remember that by is an offset of hello world. Yani where the data is, suppose it starts at 1000. So this will be at 1000. This will be at 1000 something. I will tell you in a minute in assembly. This will be at 1000 something beyond this. So these are offset of the starting address of the data, of the memory data. تمام. So these are our variables and their initial values. Remember that we can have lists, يعني مثل arrays, and we have numbers, and we can have characters. But we start with strings, then we are doing hello world. What is this backslash n, guys? You know this backslash n, right? At the end of the message, at the end of the string in Java or Python or anything, you don't say backslash n. Here you have to mention backslash n because this will be the line feed and cache return. Yani when you want to skip to the next line after writing this, you have to mention this in assembly. While in Java, for example, when we say system.out.println, so this is the ln, guys. This is the ln that in system.out.println in Java. So it is mentioned all the time here. When you practice with this, try to take this backslash n and see what happened. Okay? طيب, we come to the code. In Turbo Assembler, we used to call this code. In RISC-V, they are calling it .text. This is the program, why not? Here we go. LI A0, 4. Load immediate. You remember the addressing modes? Okay. So, load immediate in A0. You remember A0? We said X0 or A0 or T0. Now we are using A0, guys. لأنه it will be like an address of something. It's the value that will be used to do something else. I'll tell you in a minute what is it. This is a very important register, guys. Let me say it now anyways. X0, once you mention X0, it is 0, guys. X0 is always having 0 value, just like we did in any other program. We say, in 1000 you store 0, and then you say memory of this, it will be 0. Here directly the X0 value 0. A0 is very important special purpose register. هو نفس الريجستر تبع الاكس 0, بس when you call it A0 it will hold, listen to this, it will hold the function to be executed when eCall is executed. eCall is an instruction with no parameters after it, with no operands after it. eCall, what will it do? When we fetch, execute, decode, and execute eCall. Fetch, decode, you find out it's an eCall. Then, what will the assembly do? It will look what's in A0, what you have stored already in A0. We stored 4. What is 4? 4 is a special number, guys. That means, or that tells assembly to print to the screen. Wow. 4 is a special number. When you put it in A0, and when eCall runs, eCall will check what's in A0. It finds that it's a 4. For the language, it means go and print to the screen. Print what? Print whatever A1 is pointing to. You like that, guys? All these three together make it like system.out.println hello world. These 3 lines in assembly stands for system.out.println is in Java. طبعا print hello world, the name of the variable. Set for exact number. There are other numbers. I will explain them when time comes. Into A0 حطوا B0 sorry X0 حطوا A5 حطوا it doesn't work. Why? Because this instruction automatically would look what's in A0, so it loads what's in A0 and check it. It's 4, so it runs the print function. Then the print function, what does it do? It points to whatever in A1, afwan. AI now, I am pointing to the by variable. And then so it will print by. The same happens for these guys.
Doctor, but before you proceed, in line 7, always number 4.
To print.
For printing, always?
Printing on the screen, whatever A1 is pointing to.
Okay.
Always, 4 is for that. 1 is to print integers. I will come to that, بس خلينا نخلص منهم هلا. If you say 1 here, يعني you are printing an integer. If this, for example, was 5, guys, dot word 5, you want to print an integer 5, so you set here 1. If you want to exit, you set it to 10. لأنه الإيكول, when it sees 10, it means exit. And there are others. This is what I remember from the top of my head now. So again, guys, A1, after you print the by, and it will stop. Why? Because there is a backslash n after it. I said take the backslash n and see what happens. طيب. Now, we finished with this part. What are we doing now? We are making 1 points to hello world. You see, I did the second one before the fourth. It will get to that as a pointer to by, and this as a pointer to hello. So what do we have in hello? We have the address of hello with respect to the data location in A1, similar to this one. And then equal. What will this equal run? I'm asking you guys. This equal, what will it run? Which function it will run? The same function that was stored in A0. I didn't change A0. A0 is still 4. So the function that's still active is the print function, print string. You see? I don't have to say here again li A0, 4 because nobody touched A0. A0 is still 4. So I just changed the pointer. Instead of pointing to the by variable, I am pointing to the hello world variable and I'm printing it. Again, the same thing, guys, just for printing. This is all system.out.println, guys. And finally, print point to again as a variable and then print it. Okay. Look now what. Equal is working with A0 again. But this time, A0 does not have 4 in it. Look, one way to settle something into A0 is you can use this add I. You can do it this way, guys, but either way, it doesn't matter now. Showing you different syntax. You know that, middle C++, middle C equals C plus 1. Anyways. Add immediate. A0 equal X0 plus 10. X0, what did I say about X0? X0 is always 0. X0 is always 0. So 0 plus 10 is 10. Store it where? In A0. So A0 changed from 4 into 10. And now I'm not pointing to anything. I'm just calling the run function. Equal is the executing function. It will look in A0. It will not see A4 to print something. It sees a 10. So it terminates the program. Everything starts from here, guys. Everything starts from here. the skeleton of the assembly program. It is very similar to what we have seen in IAS machine, and many of you know exactly what was happening in that IAS machine. So we are translating it into different syntax. Now, let's see what's in the simulator now. أول شيء to the left-hand side of the simulator. This is the better version of what you did in your program, guys, لأنه it's visual. Your program on IAS machine does exactly what this program does. It will give you at the end the output. But here it tells you step by step what's happening. This is my program, the one I wrote, but this is in machine language, يعني translated into machine language, guys. This is the machine language. هذا الأوريجينال code that I wrote. This is what's happening in the machine language. لأنه even assembly, it could be two instruction or one instruction executed in two machine cycles. So assembly is close to instruction set of a CPU, بس طبعا with some changes. What was our first instruction in our program? هون original code. It was load immediate A0, 4. So look what he's doing now. He is doing add I, the one that I did before. I did it with what, guys? I did it with the last instruction here. So he doesn't actually execute this one. He changes, the assembly. It changes it into this. بتقول لي طب ليه ما من الأول يعلمنا بس هاي؟ No. Different syntax. And this sounds easier. So why should I go with this? And either way, C plus equal 5. طيب شو يعني؟ easy. لما تستعمل هاي استعمل هاي. It doesn't matter. And I want you to notice this, guys, now. When he wants to put the address of buy into A1, buy is a variable. Buy is a variable. He wants to put the address of that in A1. And then put it into a register called, it will point to that register in order to print it to the buy. Let's concentrate on this. أول شيء. Where this 65536 انت ما خصك فيها. انا معلمك الاسمبلي language. You don't write it. This is what you write. But how it's executed, guys? I mentioned as I was doing the code, I told you that if I go back, these are offsets of the data segment. هون وين بالميموري؟ الداتا وين بحطها بالميموري؟ نحن بالاي اس ماشين كنا نختار 10 11 15 20 100. لا ما عنده هيك. هو ببلش الداتا تبعه from this address, guys, من 65536. If you remember in binary, this is like 2 to power 8, yeah, صح؟ 2 to power 8 is 65k. 2 to power 8 is 2 to power 8 is 6a. This is 2 to power 18, 65,000. لأنه 2 to power 8 is 64. طبعا إذا ضربناها ب 1024 بتصير 65, guys. هو 2 to wait a minute. 2 to power 7 is 60. 2 power 6. 2 to power 6 is 64. Yes. 2 to power 6 is 64. Okay. So this is like starting address of the data segment. Let's go and see now on the right hand side what we have. We have the register set, guys. هيون registers. Register address, stack pointer, global pointer, temporary pointer. I believe this is what they are called. I'm pretty sure anyways. But they are special purpose register, as you see. And then we start with the rest. Like هذا الX0, guys. It's always 0. This is x0. This is x1. This is x0. This is x1. Okay. If we keep going, guys, look, can be called T1. So T0 from here on, T0 will be the x5. We use it for, as we said, parameter passing and arguments. So these are the set of registers. 32 registers from 0 to 31. Okay. You can use any of them. Okay. We can see them in hexadecimal and we see them in decimal. So you see all of them are initialized to 0, but stack pointer has an address in memory. يعني انت وقت بتقول له push دغري بيروح على هذا الادرس. And then he start adding 4 bytes for each number. A global pointer, it points to the global variables. You remember we did the global variables, static integer in Java. They can be seen by all functions. So this is the location for them in memory. Everything has a location. The interrupt handler, guys, that we know from operating system will always know about this and about that. And it supplies the control unit with that to jump here and there and get what it wants. All these now, for the time being, are zeros. They will change, صح? When we start running our program. خليهم بالديسيمال بنشوفهم اكثر. بس اوكي معلش خليهم هيك. طيب. Let's see the memory now, guys. What's in memory? What do you want to see the memory? There is the program address اللي هو text يعني .text وفي عندنا الداتا. This is address 000000 in memory. What do you think in it? Do you think the text sit here or the data? يعني this is my program ولا this is my data? 0, 4, 8. Something else to notice, guys, in assembly. بس بدي اعطيه محل زياده بس لحتى اشوف هون انه شفته كله على اكيد. Yeah, now byte 0, byte 1. Look, I'm reading here. Byte 0, byte 1, byte 2, byte 3. So this is a 4-byte word CPU. It takes 4 bytes unless you want half a byte or 1 character, then it will treat them differently. But whatever you do, they are 4 bytes. So this the PC, guys, the program counter, or we call it at sometimes IP, instruction pointer, it jumps by 4. So we simulated that as PC equal PC plus 1 to move from instruction to instruction in von Neumann or something like that. Here it moves 4 by 4. So this is 12, I believe. And so on and so forth. So this is byte 1, byte 2, byte 3, byte 4. And this is actually our program. طيب. What do I want to see now? I want to see the memory, but I want to see what? Display decimal. I want to see the data address. وين هيدي بدي اشوفها؟ اي ليك وين هون تحت هون. There is something also at the bottom of the memory starting from 0 up to certain address, and that would be our program. Now I want to see the memory, but I want to see the data part of the memory, where we have the by and again and the hello world. You remember? The heap and the stack we are not using. So we are looking now at the data part of the memory, what's stored in memory, and here it is. and starting from this address, guys. Here, this is it. This is all belongs to the memory, to the text, and this is the starting location of the data segment. So this is where the data segment starts. What was the first value stored in memory in data? The hello word, you remember? Hello or hello world or hell, something like this. Let's see if this is what's written in here. Let's see if this is what's written actually in this address. I choose to see it in what? decimal. وش كان بدنا نشوف نحن let me see if it hexadecimal. Let me see. Let me see. Where are they? We said here. This 48. No, come in. Let me see them in different way. Let me see them as text. Text is best to see our data. when as text, come in. I couldn't. Why did I change that? Oh, wait a minute. I chose data, and then I want to choose what? The data. لا مش هيدا. Now I choose here, guys. I'm just mixing this and this. Do I want to see them as ASCII? ASCII number? No. As what? As
No, at ASCII, it's correct.
Yes, ASCII will show me. Yes, ASCII. Thank you, Mark. Yes, ASCII one. And you see now, guys, you started seeing the data in the memory. This is the starting address of the memory. This is the first byte. It's stored H. Second byte stored E. Third byte L. بعدين L. بعدين this is the backslash n, guys. Then we put backslash n in there to separate this value from this value. Alhamdulillah Salime, Mark. I didn't see your name on my list, but now I hear your voice. Thank you. So the next in line is by BYE, and the next in line is AGA. So this is the data segment starting from this exact address, guys, in the memory. And when we say store the starting address of by, that was the first instruction in my program. So it will calculate this and put it. Now if we come here, guys, then we go to 65536. He added this, guys. Put it in X11 and then add +2. ليه؟ لأنه it's an offset of 2. Add 2 where the by is found and figure out the proper location of the by. So he is figuring out, this is my program. I don't know where by is. Assembly language has to find out where is that. So it will do two things, guys. It's storing it in X11. Great. What is it storing in X11? First of all, it's storing the starting address, a fixed number where the data starts at 65536. And after that, the offset of this by from the starting address happens to be 2. And now we have here the address of by in A1. Any questions? Yalla. This will complete like 80% of explaining what happens in assembly language. Then what we will be doing from now on, we solve problems. If you added مثلا 5 ولا 10, it's the same. If you reference by, ولا you reference n as a variable, it's the same. And so on and so forth. So The idea here is this is my program li a0, 4. He directly put 4 in x of 0. ليه؟ لأنه it's immediate. Now you are asking for the address of by, whatever by is pointing to be put in A1. And look, he is repeating himself here to show you that these two statements are executing to satisfy this statement. So first, an address that belongs to the data segment اللي هو دايما هيك. At any time, guys, we run, you will see 65536 as starting address of the data segment, and then it adds an offset to, sometimes you see this as minus, guys. Sometimes you see this as minus. How far do you go from where you are from the PC? Backward or forward, it will add this number as an offset. طيب. We might talk about yeah دغري ليك minus 16 دغري مسويها هون. الhello word. Let's explain. Now when you execute this guy, let's execute it now one by one. Now you see, مش هيك? You see the memory in both locations. The program location, which we really don't care about, لأنه the program is written in front of us, so we don't go to the memory with the program. We are interested in the data, what is changing in the data, and what is changing in the registers also. So now, look how we go about it. Before I explain this, let's go through this. When you say step in that simulator, when you say step, it executes the first one. Now, X10, guys, we chose to store it in LI, in A0. ليك هو وين عم ياخدنا على X10. هو لحاله عم بحطها بالX10 guys. انت بتقول له حطها بالA0 كبروجرامر. هلا اذا بنروح على X10 شو لازم نشوف؟ 4. So if we go to registers again and we go down to X10, bear with me, X10, وين X10 guys? X7, X10, هيها. This. Now we need to see it in different in different format. If we see it in decimal, then we have to see 4, I believe. X10, we are looking at X10, searching for X10. X10, and it's 4. Yeah. X10, we are naming it A0. This is the different roles, guys, as I said. نحن عملناها بالA0 لأنه it's like an offset or an address of a variable, something, so it's 4. He chose to put it in X10. Fine, ما في مشكلة. And then in X11, whatever we store in A1. And then he execute the key called step. Let me see, أول شيء هون الoutput. لأنه we will see the output in a minute إن شاء الله. الoutput هي separate لحالها. Let me close this. خليها معلش. هلا now, so far guys, we didn't execute. مش هيك? We have to execute eCall. So we say step. Every time we are executing eCall, now we are executing eCall. مش هيك? So step and look here. خليني أسكر هاي. And وين ليك هذا ما بده يروح ليش؟ لأنه I'm annotating. If I take off the annotate, if I close now, how can I close this for all the time? It's there all the time. What? I just want to close it. هيدي موجودة على طول هون. فيني غيرها؟ لا. على كل حال راح زيحها شوي. You see the by, guys? It's printed. Man, this is not the by that I'm printing, guys. This is only the name of the variable. So if we keep executing now, step, we are now doing with the hello world. Step, and what did it print? It printed, drag to move. When drag to move? هي صارت مبينة هلا. ليك. يعني دائما في شيء عم فرجيني إذا بنزل نزول هي بينه أكثر. This is the hell. Hello world is printing the hell لأنه I don't have the data here. I have it in my program. If I go back to the editor, this is the by and this is a by. Hello world is only hell. So you can change something else. You go to the simulator and then you have to start again. Every time you get out of the simulator to check your data or something, then you have to start. So if we do step, it's always the same. And look here, minus 16 and here minus 17. This is adjusting the pointer toward the data that I'm looking at. Okay, now what's with this, whatchamacallit? I was talking about something else. What is it that I was talking about? Nothing. No, I tell like minus 16, it doesn't matter. خلاص. Finally, guys, if we keep executing, step, registers are changing, values are changing, blah, 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 step. Here. When we execute this, guys, in x0 is 0 plus 10, that's 10, put in x10. Now I'm changing the 4 when x10 came 4. Look, when I execute this one, x10 will change, x10 will change into show, it will change into 10. So when I step, x10 change to 10. And now I call the equal to exit, and this is the end of my program, خلص program. I have printed the 3 messages, buy, hell, and again, AGA. Any question, guys? Any questions? Let me see. I'm gonna try something I never tried before. I know it's a waste of time for me. Right-click cut. Let me put it at the bottom. Hey, hon. Right-click and paste. Hey, ما بعرف. Now let me go and run the simulator. Run. Will it give me errors? No. هيا ليك. أعطاني نفس الأوتبوت. وين الأوتبوت؟ وين الأوتبوت؟ وين الأوتبوت؟ هيا هون. Same output. So data and text is a label, and you can put it up or down. It doesn't matter. And any questions, guys, about this program and about how to go checking if your registers are correct? And by the way, register values are very important, guys, for debugging. Usually in Java, what do we do? Print n, print m, just to check if n or m is the proper value as we expecting. So as you run here step by step, you will see register changing step by step. So if any registers change at a step that is change to unexpected value, you can tell directly that, oh, this is my error, and you fix it. Any questions, guys? Any questions? Great. Let's go very fast to do another problem, and then we stop today. This one I can now control A and delete, and then go to another problem. And I'm gonna go back directly to add 2 numbers. These are the 2 problems that I start with, even with any language I teach. Right-click, open with Notepad, and Control A, and right-click and copy. And if I close it here and go back to my simulator, and right-click and paste. Notice with the too many explanation that I did, when we do on campus explanation, guys, sometimes you don't catch something and there is no recording. So extensive explanation of what's happening at each instruction. I didn't do the first one, no, it's very easy. This one we start using numbers, guys. So I'm adding 2 numbers. The numbers are given in N1 and N2. This is like, I keep repeating myself, integer N1 equal 10 and integer N2 equal 13. And dot word, this is not ASCII, so it will not be treated as array of characters. لأنه ما في شيء أصلا ما في شيء اسمه string بالassembly. There is array of characters, guys. Like by was array of characters finished with \n. طيب, having said that also. The name, now do a program. Load the address of label N1 in T3. T3 is كمان it holds temporary locations, and I want the pointer that points to N1 put in T3. Pointer that points to N1. So now T3 is pointing to N1 into the memory. And look what we are doing now. Get the value that is stored at the address denoted by T3 load W, مش load address, load word. Where this word is coming from T3. مظبوط ولا لا؟ Offset 0. This is the syntax. يعني I have nothing to do with the syntax. This is you learn Java or any other language. So the content of T3 عفوا. The content of T3 is the address of N1 into the memory. Add to it 0, يعني no offset in there. We will see offset later on being used. When you have set of numbers, guys, here, then you have to use this, مش هيك؟ لأنه N1 will be pointing to many numbers here. So N1, hey, T3, يعني starting address of the list, and then you keep incrementing the 0 to go over the rest of the values. I am going forward to tell you what is this 0 doing there. We will do it next time, inshallah. طيب. What will T3 have? What will it have now? It will have the 10. Now 10, when we run it, guys, after you executing this instruction called load word, it will directly you will directly see 10. I was thinking about load address, guys. This load address, is there a memory reference in there ولا لا? Do we reference memory in this case ولا لا, guys? Of course we reference memory. So I'm going back now to RISC computers. And we said that we only go to memory to load into a register, and then all other instruction will work with the registers, guys. Will work with the registers. So now when you have N1 is in a register, from there on, you use this address N1, then you know it is in T3. Look, add immediate, load word, كلهم register to register. طبعا there are many of them, but when you see load address, load word, and something like this are the only وفي بعد store مش بس اللود ها بعد في store to memory location. Those are the only instructions that go to memory. The rest of the instruction will always deal with register set inside the CPU. طيب هذا كان in theory. هلا we are seeing it applied. Okay, T4 the same thing. Look here, it's repeating itself. Now we start writing programs, guys, مش هيك؟ بس I'm storing it in temporary address register 4. هلا which register it will choose when we simulate it, you will see that you choose T4, he maybe put it in X12, guys. هلا we will see. Look now, in your program, you have two registers sitting in the CPU and you want to add them. Oh, wait a minute, before you add them, what are we doing here? Set A0 to 1 denoting print integer. You remember the A0 here? It was 4 at one time, and it was 10 at one time. The 4 was to print a string, array of characters actually. The 1 is to print an integer. And now we are printing 10 plus 13, 23 as an integer. So I'm preparing to print in A0. Okay. And then I'm adding, now I want to add N1 and 2. And they are, remember, in T3 and T4. And look how it's happening. Add A0, X0, 0. What is this, guys? X0 is always 0. 0 is 0, immediate. 0 plus 0 is 0. Put it in A1. So in A1, you don't have the pointer toward like we did a minute ago, powered by or again or hello world. No, you are having now A0 as a constant 0. And look now, add 1, comma T3, comma T4. Look, this is in Java or any high-level language. T3 having the 10. T4 is having the 13. Add them, and put them in A0, who it was initialized to 0. So this will be equal to 23, guys. This is not pointing now to an address in memory. Now it's having a number to be printed. Equal, what will it do now? Equal will look into what's in A0. What's in A0 is 1. It is not 4. It is not 10. It is not any other function. It is print to screen. Then it goes to whatever is in A1 with 28 and print to 28 to the screen. And then this is the terminate. We change A0 to 10 and we equal, and this is enough. Very fast, let's go to the simulator and we see the program as it is here. And this is doing the pointing to N1 in 2 steps, guys, in 2 steps. This is the starting address and this is the increment or the offset. The offset of 0, N1 is offset 0 from the data segment. And then you know the rest here, what's happening. So if we go and step, خلينا نشوف أول شيء where شو لما نشوف T3 بأي ريجستر هو حطه بالاكس 28 guys. هي when we said load whatever is in T3 to T3 T3 load W T3 put it in T3 هو حطها بالاكس 28. So when we get to this step and execute it, we'll see that X28 has 10 in it. So step, and this, did we execute it? No, هلا step. So this one now is executed. If we go to registers X28, X28, X18, X23, X28, 5, أيها. X28, it's called T3 in my program. He changed it to X28 according to the role that it's playing, and the value there is 10. The same happens لمين؟ للT4 بدها تكون وين؟ بالX 28 مش هيك؟ So step, execute, and look, 13. These are registers inside the CPU, directly accessible. You add 10 to 13, and you put the result where, guys? In A, according to our program, in A1, اللي هو X11. We used this before. So if we keep going, when step, and add, and here, when we execute this step, so in X11, we should have what? 23, hopefully. X11, I didn't execute it yet. X11, and here, 23 is the answer of adding 10 plus 13. Oh, I changed this by mistake. Wait a minute. Can I change the register here? This is something I have never tried in my life. I changed it by hand, guys. Let me see if it will give a different answer now. No, I changed it by hand, or it will tell that there is something wrong. You cannot update register by hand. لأنه I am the simulator. I am the only one who can change this memory location. Let's see. Anjad, this is something nice. Step. What did it do? I don't know. A step. I'm waiting for the answer. Step, guys. And what's the answer here? 32. So it does allow. This is strange. I don't like that. Unless we are changing the bytes. يعني في شيء كان بالتربو assembler اسمه exchange bytes. لأنه sometimes assembly reads right to left, or sometimes read left to right. Maybe he thought that I want just to read them right to left 2 or 3. Let me try to change it to something like 55. It allows strange يعني I can do that. Let me reset the program and run it. خلص خلصنا اليوم. And let me go step by step. And when I get to that X11 and before I print it, وين صرنا؟ Where am I? 23 مش هيك؟ okay. A1 is 23. Let me say this is 55 and see if it will work. Did I run the whole thing? Oh, بعد I ran the whole thing. Go back في feedback مش هيك؟ في شو go back previous previous. بعد ما في جواب هلا حطيت 55 before printing guys. So let me now step ما خليني خليني previous. Okay, let me say now step. Okay, and step, and he printed 23 ما خلي you see this 55 guys. He didn't change it or something or خليني شوفها هيك. I don't know. This is something for you to play around with the language. This is only a simulator يعني إذا بيقول لك I trust your integrity not to change my registers, and he is not and he's allowing you to change for some reason, then it has to do with the simulator. طيب هلا I am done, so let me stop recording and